So here we are at annuities due instead of an ordinary annuity. The difference is the timing of the payment, okay? They've all been shifted forward by one time period. So it now begins at the beginning instead of the end of the time period. New formula. Let's find, let's see. Let's compare that to the other formula, which is right here. So this was the other formula. Let's just bring that so you can see that. See if I can really mess this up for you. So that was the formula we used for the end of the period. See that? And this is the formula we use for the beginning of the period. Gives us a different factor, but it's so our amount is different. This amount was, I think, 2810, as I remember, yeah, right here. And now, because we've shifted it, the amount is 2987. Now, what's the easiest way to calculate this? Well, it's time to go to the good old Excel. And here's our formula. We're using the same formula, future value, same numbers here. The only difference is we've added a 1 on the end of this formula. So it looks like this, when you're creating it, equal if the parentheses, so my rate is the same, right? Comma, years, periods, comma, payment. We're skipping that PV, but instead of having nothing for the type, we're putting in a 1. That switches it to the annuity due and gives you. So all you have to do is say, oh, we're changing that. You come up here, add a 1 right there. It will take you right to where you want to go to get the numbers that you need to know on that. Pretty nifty, huh? So Excel is wonderful for this kind of stuff. Let's look at the next one is an amortized loan, and we do these all the time. Home mortgages, home loans, autos, anything where you have a payment due out where they reduce the value of the loan via annuity payments, and this is called amortizing. So you have an amortization schedule. So what does this look like when we do calculations? Let's look at figure 4. So what does that mean? Well, at the beginning of the loan, or the beginning of the payment period, you pay much more interest in that payment. But as you start paying it off, you're paying off the principal. So your interest is going down in relationship to the payment. So when you get all the way to the end, you're paying much more on the principal than you are on the interest. So it's sort of a curve down. When you buy a house, with the first 5 years, you're paying nothing but almost nothing but interest. But as you pass that curve, and the number of periods each payment you make, you're paying a little bit more on the principal and a little less on the interest because of the amortization. And here's an example of your payment is going to be, let's see, what have they given us? We've purchased a new item for $6,000. The interest rate is 15% over 4 years. What will your annual payments be? Well, you have to find the payment. And the formula for that is payment equals 1 minus 1 plus the rate to the power divided by the rate. And you end up with $2,101. If you do this formula, you come up with this factor. You multiply or divide it into the 6,000, and that will give you the payment you will pay each year, evidently, yeah, over an annual payment. Now you can do the same thing in Excel, and it looks like this. Again, here's the rate, here's the periods, here's the price. This is the formula. So to do this, you just type in equal payment, or PMT, and then I put the rate in with a comma. I put the end periods in after a comma, and then I put in its present value, what I'm paying for it today. And that will give me the payment for it of $2,101. As you can see, that's a really nice way to do it. It's very quick and simple. So as you can see, now here is the thought here. You have $6,000. You are going to make equal payments for 4 years. So the first portion is 6,000 times, what was the rate? 15%. So 6,000 times 15% is $900. So that is the first portion. That's how much of the first payment is going to be interest. If you take that 900 and subtract it from the 2,101, this is the amount that's applied to the annuity. That makes the remaining principal 4,798. You multiply that times 15%, that becomes the interest portion of the payment. Subtract that from the 2,101, and that becomes your portion of the amount paid on the principal. Subtracted from 4798 gives you the remaining principal, and you just continue that. So that's kind of how it amortizes, and you can tell what your interest expense is versus what your carrying value of it. So the next thing they come up with, quoted versus effective rate. So a lot of times we compound not annually, but we'll compound quarterly, or we'll compound monthly, or sometimes even daily. So when you do that, even though the rate that's quoted is, say, 5%, when all of this compounding is taking place multiple times during the annual year, you'll come up with a different rate, effective rate, and that's called APY, and or EAR. So the quoted rate can be different from the effective rate of what the loan or the annuity actually yields, okay? And that's because the compounding is not done annually, but it's done several times throughout that annual period. So you're actually getting a little bit of a, each time that is compounded, that adds to your principal and then adds to your interest the next time. So they have an example here, and this is the formula you can use. It is 1 plus the rate divided by the number of compounds to the power of the number of compounds minus 1. Calculating this all out, it comes to 101.01 to the 12th power minus 1, or 12%. So you can use a formula, but guess what? You can also use Excel to do that. So you simply put down the 12% rate and the number of periods and set your formula up here. So the formula is 1 plus the rate divided by the period. Let's go back up here. Divided by the period to the power of the rate. I may have that switched. To the power of, oh wait, I do. To the power of the period minus 1. And then you can just play with these two. And you can change them, and your formula will change with it. Let's say there were 10 periods. Let's see what it's going to do. Changed it just a bit, not enough to really, if I change that to 2, my effective yield would be 1236 instead of 1268%. So you can see, then you can play with this. This is your formula. You just plug it right in here using the exponent. So that's very nice, and it's much quicker, and you can play around more with it. So those are quoted versus effective rate. There are a lot of tables out there that explain, that already have these calculations in them for you. So all you have to do is really search for those, and they'll tell you the difference in some of this. There are also tables out there to help you use a factor to do this. So there's lots of help. But it's nice to know this basic formula. So if you get caught out there with nothing, you'll at least have the formula, and you can crank it out, by hand. So then they talk about finding the present value and the future value for non-annual periods. What you're going to have to do is, when they say it's compounded, what have they got here? Quarterly. You're going to have to break the percent down to a quarter, and you're going to have to break the periods down to, expand out the periods. So at 10%, if it's done quarterly, right, that's going to be a fourth of 10%, or 2.5%. And if it's done 4 times a year for 10 years, that period's going to change to 40 when you start doing your calculations. You just have to remember to compensate for the differences. And then we have a perpetuary. Watching that fast caught me off guard. This is called a perpetuity. And a perpetuity is an investment that goes on and on and on and on and on forever into infinity. If there is anything such as that, but there are several things that we really can't tell the end of its life of, so we use the perpetuity formula, which is really kind of easy, and you can do this in your head. It is the present value of the perpetuity. That's what we're looking for, the present value of it. What is the constant amount provided by the perpetuity? Meaning, what is its growth? How much is it? What is it going to pay back forever and ever and ever and ever? And then you want the annual interest rate or discount rate. So here's an example. Present value of $2,000 perpetuity discounted back to the present at 10% interest rate. You simply take that present value, divide it by the interest rate, and that gives you the present value, or the value of that perpetuity. It's a very clean, neat equation. It's very easy to use. So, and this you're probably going to use. You'll use this for stocks. You'll use this for a stock, the return on a stock, to see how much that investment is worth, the present value. And we'll use that in the future. Now, let's look at one more thing, and then we are going to be finished with this particular chapter. We're going to be looking at, we've talked about this over and over again, risk requires reward. And when you're dealing with money and you're trying to calculate what it will be in the future, there's a lot of risk in it. And part of that risk is reflected in the rate of inflation, because inflation can go up or down. And when the inflation rate goes up, that money is worth less, so you have to compensate for that by giving interest or by paying interest. Now, in the United States, we're relatively stable on that. But in many foreign countries, we aren't. So the interest rates are very volatile, and they're difficult to predict. Look at Argentina in 1989. I can remember this. The interest rate was almost 5,000%. Yeah, that's right, 5,000%. And then it dropped, and then it was at 84. And right now, at 2000, it's at 0. how do you even think about finding a discount rate for a bond at that? So there are some difficulties with that, and it makes it very challenging for international companies to choose an appropriate discount rate when you're trying to move money through time and trying to compare apples. And apples bring all that money back to the same value. Keep that in mind. Here's an example of an uneven stream. And what you'll end up doing is doing them individually, wherever that uneven is. And then where it evens out, you can start using your present value, some of your formulas to pull it back. Just an example of that. And this shows adding it up and how they did it. They broke it into chunks, and that's what you need to do, is to break it into chunks. Again, you have to remember these are all approximations, especially where you're looking at that discount rate or the cost of a company's money, the cost of equity, the cost of borrowing. Sometimes we use a lot of estimates, so keep that in mind. In the book, there is a list or a table of all the formulas we've talked about. So please, kind of look at these, keep them in mind, but we will be using, for the majority of the time, Excel to do these calculations. And I'll do an entire little video to help you know how to do these. All right? So, thanks for listening.